Hi, all. I want to take a brief moment to thank you all personally for supporting this podcast on YouTube and on all major podcast platforms, including Google Podcasts and Spotify. The podcast mainly features interesting people in robotics, artificial intelligence, and entrepreneurship. If you believe that the information that I'm providing might be of benefit to you or to someone you know, it would be really great if you could hit the subscribe button and press the notification icon so that you can get notified on time whenever the next part is out. It would literally take you a second or two to subscribe to the podcast, but it would really mean a lot to me because I can grow the podcast to a level where I can reach more people, invite ever more interesting guests, and have a more meaningful impact. So let's begin now. Okay, so in this podcast, I also include a new section called the Building Culture Curriculum Breakdowns. And since both of us are studying our masters in Robotic Systems Engineering at RWTH Aachen University, so we will try to break down the whole curriculum of Robotic Systems Engineering and try to explain a bit, briefly of what each of these subjects are, how the curriculum is designed, how you should be choosing your electives, and all these things. Sure. So, okay, Vamsi, now let's talk about the program structure, how the overall structure of robotic systems engineering at our university was.
Yeah.
Can you give your view of the overall structure and how it is designed and why it is designed? We can also talk about that.
Sure. Yeah, we are not experts actually, but we can share
our own experiences
yes. Which would help you guys. So, in my view, the robotic systems curriculum is designed pertaining to development of robots, programming, or maybe application of robots. So there are multiple modules, so you can choose upon to define in which area within robotics systems you would want to go with, or maybe something you might be having some different perspective. Yeah, you can share with that.
Yeah, you're right. I mean, it makes sense that it is structured such that you learn development, design, programming of robotics, and research aspects of the variety of different subjects that are related to robotics, right?
System.
So I'll share my view. Maybe you can share your view after that, and we can have a discussion regarding this. So I think, so semester-wise, how the course is structured is that in the first semester we have this interdisciplinary kind of arrangement, such that we have subjects ranging from machine learning to kinematics and dynamics, which would be more towards the mechanical side of robotics. And also when we were studying, we also had electrical drives. It was kicked out because it was too difficult. We will talk about that later. So I think in my view, in the first semester, how it is structured is that you study the fundamentals of all the different subjects,
streams within robotics.
All the different streams within robotics, and in the second semester what happens is that the course is narrowed down a bit such that we have now just 3 mandatory courses and all of the other courses are electives. And so I think the mandatory courses are such that we have 3 different streams. So one would be computer vision, one would be sensor systems, and one would be multi-body dynamics. So multi-body dynamics would be mechanical, sensor systems would be electrical, signal processing side of things, and computer vision would be the artificial intelligence and programming side. So this is like, then you kind of have to choose between these 3 streams. In the third semester, you have just one mandatory course, which is simulation of the robotic systems, and all the other are elective. So the idea, I think, is that by the time you go from first semester to second semester, you get some clarity of which stream you want to go in, and then in the third semester you get even more. You should be totally clear which direction you want to go in, and all of your electives are aligned with that. Maybe I'm wrong, but this is just my perspective. What do you think?
Yeah, obviously what you said is absolutely true. And so the elective courses, the mandatory courses defined from different backgrounds of the streams of robotic systems. could be a design part, could be mechanical kinematics, dynamics, it could be artificial intelligence, programming part could be sensors, simulations. So once you are thorough with your mandatory courses, you will have a definitive idea on which stream you would want to go. So then elective parts are you can choose upon, like whether you want to go with artificial intelligence. In my personal experience, I felt like I would want to go with AI and machine learning. So most of my electives are related to machine learning and artificial intelligence. And then you can choose upon whether you want to design robots, you can choose upon finite element methods, you can choose upon MDOs, nothing but machine dynamics of rigid systems, and maybe lightweight design of multi-body systems. These are the courses pertaining to design of robotics, design side of robotics,
the mechanical design
of the robotics. Or nevertheless, you will also have some electives which are related to control part, where you, as a mandatory subject, you will study control engineering. As an elective subject, you will be studying advanced controls. Also power electronics, advanced electrical drives, which are more or less
electronics
and electrical part of robotic systems.
Because robotics is such an interdisciplinary field that it's also very difficult to define your own interests, and so it takes time. So I think it's a very logically designed curriculum. I think.
Obviously, so I'm agreeing with you. Like by the time you finish your your mandatory courses, you will have a definite idea in which way you would want to. Also, it's not just limited for development of robots, development of robot parts. There are also some elective courses which are like factory planning, industrial logistics, which helps you
this is
to.
Also if you want to go into the
application of
robotics, like you don't want to go into the research side of things, you want to be a bit more managerial as well,
or maybe research oriented also, but how you apply robots
implementing in for example logistics industries, and
as well as factory planning, how you can when you study factory planning, you will understand.
But can we classify this whole thing as under a managerial criteria or something?
I wouldn't say, because according to my opinion,
factory planning and logistics, for example, this is more like managerial, right?
In my view, you can consider them as areas where you will apply your robotics knowledge. So by studying factory planning or industrial logistics, you will come to know how and where the scope of robots and at industry level. So for especially today's market, more or less robots are playing major role in industry front as well as in logistics front. So like Amazon working with logistic robots.
So implementation of robots in the whole pipeline, but it's not probably purely managerial, but there's like managerial aspects to it,
within that.
Because I think I have not taken factory planning, so I cannot tell about that actually, but based on what I hear and everything, so it is about how you can implement these robotic systems for different
better
purposes.
Factories, for better factory environments. So how automation would help you. So it will help you such subjects. So the main idea is like either you can go with mechanical side development of robots, or you can choose upon artificial intelligence and machine learning perspective. Either you can choose upon artificial intelligence or machine learning area, subject areas, or
which would be more programming
related. And also you can choose upon electrical part of robotics, like
electrical drives, power electronics,
electrical drives, control engineering, advanced control engineering, and also you can choose upon application of robots, like where and how you will apply robots. Also, one pure managerial subject is included here, which is nothing but strategic technology
Strategic
management.
technology management.
We-
So actually, this is something that is really good as well, because
Yeah.
then you also have the option to choose a managerial path.
I have taken up that course, and in my experience or in my view, it really helps for an engineer. So how, because the course explains how disruptive technology is and strategically how you manage technology. Whether how whether you will come to know the value of the technology, valuation of the technology, and how disruptive technologies work. So when you are in a stage, maybe in future, even for it applies to us. Like,
Yeah, exactly.
So at one point of time, if we move to managerial level, then we would be having the authority to choose upon which technology should we consider, which we should not consider.
Okay.
At that point of time, it would help you, like how the robotic technology can be, what robotic technology should be developed, or what robotic technology should we invest upon. So one subject which is totally managerial
is
we have
strategic technology management. So yeah, I mean, to summarize, I think both of us have probably similar points here.
Yeah. To summarize, maybe I will explain with respect to curriculum overview. Like if you look into the curriculum overview in the first semester, you will have more or less all the subjects were compulsory subjects, which are mandatory courses, and you have chance to choose one elective course where you can choose upon any of these subjects here. So here in mandatory courses, you will be studying robotic systems, advanced robotic kinematics and dynamics, control engineering, machine learning, and computer science and mechanical engineering. So these are more or less give a basic understanding of robotic system pertaining to different disciplinaries. And in coming to second semester, you will be having 3 subjects which are multi-body dynamics, computer vision, and robotic sensors and systems. So which is multi-body dynamics deals with mechanisms. And coming to electives, you will have different streams and different courses with pertaining to different disciplines. And in third semester, you will be having only one mandatory course, and rest all subjects you should pick subjects to complete 25 credit points. You would pick the in each and every semester for electives, you pick the courses for mentioned credit points here. Maybe in the first semester you will be picking for 4 to 6 credit points. In second semester it will be up to 12 to 14 credit points, and in the third semester you will be picking electives which should sum up to 25 credit points. So after successful completion of 3 semesters, you will be landing into fourth semester, which is a very important semester where you will study where you will work on either internship for 3 to 6 months, maybe in the companies, or maybe you can work on work at institutes as under research project, which is an academic track. It's based upon your interest. Either you would want to pursue your internship at industry, or if you want to have a research project at the institute. So after your internship, you will be doing your master thesis, which we both of us are doing right now. Of course, you will have to take one German course as a compulsory the curriculum. So this overall curriculum for robotic systems. So as we have already discussed, pertaining to multiple disciplines, by the end of your first semester, or by the end of your second semester, you will have a clarity whether in which direction you would want to go.
Now, Vamsi, thank you very much for explaining in depth about the overall curriculum structure. I think that would be beneficial to a lot of people who are already enrolled or planning to join. So now what we will do is, now we will take up one subject individually, one by one. We'll take the subject from each semester, and we'll talk briefly about each of the subjects. So in the first semester we have Robotic Systems, RCAD, which is Advanced Robot Kinematics and Dynamics. If you can say the whole name, you can keep calling it that, but we will call it RCAD as we do. And the next is Control Engineering, CSME 2, Computer Science or Mechanical Engineering 2, and Machine Learning. So these are the 5 subjects that we have had. The 6th subject is a forbidden subject that we will talk about later. So Vamsi, I think Robotic Systems was a subject that was really simple because we didn't have to study a lot except the basics. I think DH parameters,
Yeah.
and the degree of freedom part was covered in a lot of depth, and you could get a good understanding. But apart from that, it was comparatively basic compared to RCAD, for example,
Yeah.
which was also bit similar.
Yeah.
So what is your view on robotic systems?
Yeah, robotic systems gives us an overall understanding of what a robot, maybe what are the elements and what are the disciplines involved in
So
robotic
systems, as the name
Yeah.
suggests.
So what and all the different kinds of systems, like what are the mechanical part, how you define degree of freedom, basics of manipulators, and basics of mobile robots.
Yeah.
Robotic systems actually divided into two. One is manipulator robots and another one is mobile robots. So what is the basic architecture, basic understanding, how degree of freedom, basic mechanisms, and how basically it will give you
overall understanding of the whole thing, even including sensors, transducers, controllers, and everything.
You won't go into deep, but you will have an overall view, like what it is actually a robotic system.
Exactly. Yeah, and the exam for this subject was online. So this, I think, it was a relatively easier subject compared to the other subjects.
Yeah,
right?
In our experience, robotic systems is quite easier when compared to other subjects.
Yeah, because it was more theoretical, except the DH parameters, inverse, forward.
And yeah, as a part of coursework, you will be working on real robot, where at a laboratory at IGMR you will have a robot from FANUC, which is also called as FANUC Education Cell, which is
RoboCell or something.
Education Cell.
Okay.
It's basically that robot is meant for educational purposes. So there are robo guides, which is a simulation environment for FANUC robots, and also. So
wherever you go, FANUC follows you.
I feel good about it because I work there, and when I moved here, I see FANUC, so it's good for me. And so. So
the overall exam was just theoretical concepts, but there is like a few mathematical numerical based calculation based questions as well, from DH parameters, inverse, forward, kinematics, and degree of freedom calculation. And we get one really lengthy question about DH parameters, a really hard one, the hardest case that you can imagine. They give it in the exam, but the rest of the exam is, I think, more theoretical and easier. So according to us, we are not experts, this subject is relatively easy. Now this is a huge jump, Vamsi. So the robotic systems to RCAD, advanced robot kinematics and dynamics. I think this subject was totally numerical based, and you had to practice a lot of mathematics, calculations, everything. So this was a bit challenging, this subject, but also a good learning experience as well.
And it's must for every robotics engineer. Like you will study the kinematics and dynamics, especially for manipulator robots. Of course, you will study about mobile robots at a later point of time within the same subject. We'll start with manipulator robots, nothing but articulated robots with ranging from 1 degree of freedom to 6 degree of freedoms, or maybe more as well. So what this subject basically deals with is you will study about how the degrees of freedoms are framed, how the kinematics are framed, how the dynamics are framed, and the control part of kinematics and dynamics of robots.
Various algorithms for calculation, Newton, Euler, Lagrangian,
and also like DH parameters, basically more or less like mechanisms of robots. you will study this subject.
Exactly. So I think this is more towards the mechanism or mechanical part of robotics. So DH parameters, the optimization the algorithms, Newton-Euler and Lagrangian, and inverse forward kinematics, and
also
about mobile robots.
Also trajectory planning.
Trajectory planning as well.
It's
exactly.
very important for robotic systems.
Yeah, so this subject was a bit harder because it was more calculation based and the exam was also online. But the good thing is that since it was online and the exam was multiple choice based, then and we were allowed a calculator and a sheet of formulas as well. So one thing that I also like about studying here is that you don't have to memorize formulas.
Yeah.
I think RCAD was a really important subject, but also a bit
and
difficult.
also quite interesting as well. Because you will be studying mechanisms, kinematics, and dynamics, which is a basic robotics.
Essential department for every robotics engineer. So now let's move on to control engineering.
Yeah.
So this one I think was a more fundamental one. It was similar to the way that we study control engineering in bachelor's. You are also from mechatronics background, myself as well. So this was more or less the same, but the way that it is taught here is a bit different. We have terminologies like this PT1, PT2, and of just the classifying the control curves.
Yeah.
But the way it is taught is different, but I think it's more or less the same. Talk about the exam format for this subject.
Exam is written exam, so actually it's just 1 hour exam, and as it is a basic course, not much stress is involved in this particular subject.
Exactly.
But more or less it is similar to the syllabus what we studied in bachelor's. So yeah, it's quite the basic control engineering part, and it is taught with real-time examples.
Yeah, and so also just to point this out as well, like in Germany we have this one lecture slot and one exercise slot generally for all of these subjects. So for this control engineering, what we have is that we have similar structure, and exercise part is the most important thing for the exams.
Yeah.
Because all of the exercises that you do in the exercise session, they would be maybe a different version of it would come in the exams, but it would always be exercises and not theoretical questions for this subject. Anything else you want to add for control engineering?
I think nothing much about that, because more or less it is similar to bachelor's.
It is similar to what you study in bachelor's, but focus on the exercises is what we would just like to say. Then the subject that we don't want to talk about. I won't talk about it. You talk about it.
It was a pretty difficult subject for most of us. It was our experience. Maybe it would be different for you.
For majority of the people in our course, I think they would agree.
Found it difficult. But it is very, very interesting and very important subject, because more or less you will have a background or have a basic understanding of how computer science is involved in mechanical engineering, where how the algorithms, how you use probability to control mechanical systems, how you relate machine learning, all
the AI related
stuff. But of course it's basics, but you will learn a lot about machine learning.
Overall understanding of how computer science is implemented in robotics and mechanical engineering.
Basically in mechanical engineering, of course you will learn, or you will study more robotic examples in CSME subject, because more or less robotic system is a mechanical system which is controlled with software and hardware, electronics hardware. So It's quite interesting and quite challenging to attempt exam actually.
Yeah, I think this is a really interesting subject because, yeah, as you mentioned, we have this AI and programming side of robotic systems. You get introduced to all the different areas from, Kalman filters and, the even breadth first search and machine learning side of things, AI in general,
And programming
trajectory
side.
planning, programming side.
So
All these things you get introduced to. But I don't think it would be just fair to call it just introduction. We go deeper.
we're going deeper, like how these
subject.
things would be applicable in mechanical systems, how programming can be used in mechanical systems
Exactly.
or mechanical engineering. But of course, as it sounds so interesting, but exam was a bit hard.
Exam was quite hard, and I think this is changing. I think the people who came a batch next to us, for them it was a bit simpler the exam, and also they had an internal assignment which was also graded, so for them it was not a problem. For us it was a problem. Exam was really hard. I'll talk about what to focus on for this exam. So this is also here. You have to focus on the exercises a lot, but also here you get theoretical questions. But mostly this is important. Vamsi, can you talk about the how the exercises are structured, because this is very different the way exercises are in this subject.
Yeah, actually, the exercises were quite relevant to the lectures of the previous class. But exercises, the exam formats are more or less what you study in exercises, but could be something more difficult or maybe in the exams actually.
Yeah. So that's the thing. Yeah, I mean the examples or questions that you get in exam for this particular course would be harder as compared to what the exercises that you do. And also another thing that I want to point out is that the exercises are structured such that you get a practical example. So for example, doing localization for a drone or how a ball would be falling, the dynamics of it. So I think the exercises are like, it's a very good way of getting a practical
understanding of how you apply computer science in mechanical engineering.
Exactly. I think there were no programming assignments or anything, but the exercises were such that you gain practical knowledge of how these algorithms, how a Kalman filter would be implemented, how other AI algorithms would be implemented. So yeah, I mean, so I think the course was good, but the exam, we won't say much about it. Now I think I placed it a bit at the bottom. So the next course is Machine Learning by Professor Bastian Leive. Machine learning, I think, very, very important, because this thing is being used in robotics, all kinds of robotics applications, in fact everywhere, not just in robotics. So very important subject. And this course was, I mean, in the beginning, I'll just share my experience and then you can talk about that. So in the beginning, this was a new subject for me at least, so it was very challenging for me. And the reason is that because comparing to courseworks online, it is a bit more complicated, because this goes very deep, all the derivations,
even mathematical, in the programming level.
So it covers everything in depth. So that's why it was challenging to get hold of all the mathematical foundations. Coming from a mechatronics background, even you don't have any foundational knowledge for this field. So this was a bit challenging, but what I really liked was that this course was really thorough, and recent research papers and everything were included in this. And I think this is a very important one as well. So we made it sure that we focus more on this subject as well. So Vamsi, what was your take on machine learning?
Machine learning, of course, it's quite interesting by the name itself. We will be studying basically two parts, like a basic machine learning algorithms and deep learning as well within this subject, where you will learn about neural networks, convolutional neural networks, and maybe basic machine learning algorithms as well. And of course, again, the coursework is structured in a way that it's more or less programming part of machine learning. So you will have real-time experience of how the algorithms which you study in lecture you will learn it in coursework, but it's a bit different here.
So in exercises also we get programming assignments.
Yeah, so it is highly recommended to attend each and every exercise classes as well along with lecture classes, because where you will have a deeper understanding of how to program,
how to implement it, and I think we also got introduced to TensorFlow as well. So for starting, it is very good that you get to know TensorFlow, PyTorch, and do basic, implementation of machine learning algorithms for that. So
if you are aiming towards AI part of robotic systems, maybe you may attend each and every first. Actually, here in machine learning, it will be like you will be given a task 2 weeks before or a week before.
Exactly.
You are asked to solve it and submit it the task, and it won't be graded. It's fortunately it won't be graded in one way. But
fortunately, but
unfortunately, thing is your complete marks is relied on final exam only. So in a way, it is a good thing. In a way, it is like a
bad thing because you miss out on doing the exercises. Because the thing is that during our first semester, at least the courses and the classes were so much that it was difficult to take out time to do the exercises. But if you can take out time, then it is very highly recommended.
If you are planning towards AI scope of robotic systems, then it is recommended to do all exercises, and because it involves deep understanding of Python, especially Python programming, and also the libraries. And it's not just you will be using the libraries, you will have to codify the math what you learn in lectures.
Exactly. So you'll have a strong foundation of machine learning. Exam point of view, lectures are super important, but if you want to be an expert in machine learning and you want to gain practical skills, then exercises are also important in this case. So with this, first semester is over. Enjoy your break. With break, let's talk about how we don't get any breaks after the end of semester at RWTH Aachen.
Actually, theoretically, you will have breaks, but in reality, it will be very difficult because you would want to complete some subjects. So sometimes it is depend upon the course, sometimes it is depend upon the schedule of exams.
Mostly it depends on the schedule of
the exams. So sometimes you will have a span of like 3 months entirely dedicated for exams. Sometimes you will have a schedule maybe like 2 months or 1 month, within 2 months most probably. So in our experiences, we would suggest like not to hold any exams or not to skip any exams in any semester, because it will be piled up in the next semesters.
But depends on the personal goals of the person.
Again, so sometimes if you are giving like 6 or 7 subjects in a semester,
it can be challenging,
and it will take around 3 months for you to complete all the exams, or maybe 2 months to clear all the exams.
But generally, why I mentioned that it's difficult to get breaks is because of the scheduling thing, right? If you schedule all the 5 exams, maybe in the last month of exams, you have one exam at the end, and probably you have just one exam in the beginning of the month, so you have like 25 days or so in between. So that would technically be called a break, but since you have an exam at the end, probably that wouldn't be called a break. So it depends on the scheduling of how many subjects you take and how you schedule your exams.
Your curriculum, which subjects you take, which exams you would want to attend at that particular semester.
Exactly.
So of course, break is required. So between semesters, you can go around the NRW and you have a semester ticket.
So you can, if you can manage some time, then you can travel around and utilize the semester ticket during the breaks.
And you will have one elective in first semester. Maybe you can choose upon from the curriculum. Actually, when we were attending our first semester, we were not having any electives in first semester. We were having advanced elective drives, which was then moved towards elective, considering the
difficulty of
and,
the subject
and considering multiple parameters, because we were not typically electrical engineers, and the advanced electrical drives is quite advanced.
Yeah. Before it was called electrical drives, its name changed to advanced electrical drives. So I mean that's sufficient to talk about advanced electrical drives. You also gave the exam, right?
I gave the exam.
So we will talk about the exam as well.
Sure.
So moving towards second semester now, as you mentioned, we have multi-body dynamics, computer vision 1, and robotic sensor systems. Luckily, I placed it in the right sequence.
Yeah.
So, Vamsi, as you mentioned that the first subject is pertaining to mechanical field, the second one is more towards machine learning, AI,
programming. Yeah.
Yes, and the third one is towards sensor systems, electronics part.
Signal processing part.
So here we think that having these three options, you get more clarity as you move to the second semester on which are the electives that you would be choosing. So let's first focus on the compulsory subjects. MBD is the subject that people are really scared to talk about, because this subject is also what CAME, the computer aided mechanical engineering, people also take. And it is also a mandatory course in our curriculum. It is considered to be a very hard subject.
Yeah.
But I don't know if it can be called very hard, but I think in my view it's similar to how CSME is, because the curriculum is it's understandable, although you would have to spend efforts, but the exam is really hard as well.
Exactly. And it's more or less similar to RCAD, but in a different way. RCAD is concentrated only for robotic systems, but MBD is more or less for any general mechanical system. Like
so mechanisms is what the focus of this subject.
So any mechanical system, consider an automotive vehicle, consider a bicycle, or any part which is moving and which is interacting with forces, which is interacting with environment. And also the multi-body dynamics basically deals with how the dynamics of a body vary with respect, considering a whole system as multi-bodies. Exactly. Which is a bit different from finite element analysis, a bit different from continuum mechanics. So the whole body is now considered as split into multiple bodies, multiple rigid bodies especially.
But with articulations. So for example, a robot arm can also be represented as
one multi-body system where each and every link is a one rigid body. So, if you deal with MBD, or if you study MBD, you will have an understanding how we can apply these MBD techniques or in development or design of robot mechanisms, especially robot dynamics, robot kinematics.
So the softwares that you would be using as a CAME student, if he would be working in this area in multi-body dynamics, the M.Sc Adams, where you would be having visualizations of links and moving the having the movements, how the kinematics and dynamics of the mechanism would be. So this thing is also pretty interesting. Sure. But from a curriculum point of view, this is also totally mathematical, and exercises are super important for this.
So in our understanding, any subject which is more numerical based, you should concentrate on exercise part. And if any subject like programming based, which then you can concentrate on lectures part. Yeah,
because you don't have a programming assignments for exams, right?
But in exams they might ask you programming to write some programs, like some subjects like artificial intelligence and all.
Exactly.
But more or less you can concentrate on lecture parts for program related subjects, and any numerical based subjects, it's more or less
exercises are more important. Yes. So also Vamsi, multi-body dynamics is considered very hard as well. Do you agree with that, or?
Yeah, actually it's hard. by first experience, but you can see similarities along with arcade. So it's, of course, it's hard, and it is also not like it is not so hard as well. So in my experience, like, it is not like it is too impossible to pass in the exam. It is not too impossible to get a good score. It is possible to have a good score, but
I think the exams are such that the exams are structured more difficult, and for us, I think the format also keeps on changing every time, and now they are doing online exams. When I gave the exam, it was the pen and paper written exam. So I think the exam when I gave was hard. I think when you give online exam, the difficulty decreased a bit. So Vamsi is in a good form, explaining the subjects really well. He's wearing the RWTH Aachen University shirt. His mug says RWTH Aachen. So he's the RWTH man today.
I'm quite excited to speak about my course.
So moving on, let's talk about Computer Vision 1, another course by Professor Bastian Leibe, who structures his courses in a very organized and detailed way. So I personally enjoyed this subject very much because this is more visual. Also, of course, mathematics is very important, as is with Professor Leibe's courses. He lists down the recent research papers and all the mathematical derivations as well. But Vamsi, talk about Computer Vision 1.
My personal experience with this particular subject is quite interesting. Like, so if you are a program lover, or if you're you like programming, AI, and machine learning, you will definitely love this subject, because this subject is more or less like how vision-based applications are solved in industry level, as much as like the algorithms for vision, computer vision. The subject is more relevant to robotic systems, because computer vision is one of the way to perceive the environment, and nowadays it is playing an important role for robotic systems in multiple application areas, like pin picking application or localization,
creating map of the environment,
or maybe pose estimation for robots, imitation learning especially. So computer vision is playing an important role for robotic systems.
So that's why it's in our curriculum, and also the way it is structured is that it has the conventional conventional computer vision approaches, like that deal with image processing and a lot of older techniques, plus the machine learning and deep learning ones, which are being increasingly used now. So also let's talk about the structure of the course and its relevance to the exams.
So it's more or less pretty similar with how the course structure was organized with machine learning. You will have lectures and you will have exercise slots. So once even here, the exercise slots were more or less programming related, which you will be coding in Python using some packages
like TensorFlow, PyTorch for deep learning, machine learning applications, but also we had MATLAB exercises for conventional computer vision techniques,
and also like OpenCV libraries. So the lectures and coursework, so the lectures and exercises were well defined for this particular course. And it's quite interesting.
And so talking about exam, as with Professor Leibe's courses, it was more theoretical, and as you mentioned, with programming related stuff, the exams are more theoretical with a few programming related concepts that they might ask you in a theoretical way. Overall, I also personally really enjoyed this particular course. And any other tip that you want to give for Computer Vision 1 regarding its preparation?
Regarding preparation wise, if you concentrate more on lecture slides, that's more or less enough for exam. You will have very less part of programming in our experiences
in the exams.
but there will be some part but they will in the exams you will be asked to write some algorithms in pseudocodes, not in programming way.
Yeah. So algorithm, you can describe the algorithm
in pseudocode, or you will be asked to explain an algorithm, how algorithm works, but more or less it's not more into programming exams.
Exactly. Now let's move on to the third mandatory course, Robotic Sensor Systems. This one, I think, was a mixture of theoretical and exercise-based, numerical-based questions. And the good part, so the details I'll let Vamsi explain. I'll just give a brief overview of the good part of this course. The good part of this course is that you get, as with a lot of other courses, you get to take a sheet inside the exam hall.
Yeah.
And you won't be caught for cheating. And in this,
it's not cheating, guys.
It's not cheating. You're asked to take this, and in that sheet you can write all the formulas and also a bit of theoretical concepts you can write for this particular course. And the reason for this is because they don't want to test your memorization skills, at least for some courses. So talk about the details of this course.
Yeah, the course is structured more or less like what are the different types of sensors based upon their physical properties. Maybe, for example, electromagnetic sensors, temperature sensors, vision sensors. So basically, they will give introduction about what is a robot and how robot perceives the environment. Exactly. So a robot without perceiving an environment is of no use.
Exactly. Think about you as a human. Without senses, you are nothing. So same for
it's
a robot.
a mandatory element in the robotic systems. Like you will study about encoders, decoders, as well as motor encoders, and some sensors like vision sensors, some sensors like temperature,
thermal sensors as well. So just an overall understanding of the sensors and transducer systems.
So it's not just about sensors and transducers, also like how you will apply those systems.
Also, so that's why we have numericals as well. So you do calculations as well on calibration of cameras, for example, and other sensors.
Also, you will study about some signal processing techniques.
Signal processing
because
as well.
Perceiving is not just about sensing an environment, also like processing an environment as well.
Exactly.
So, for a robotic system to have a successful perception, should have a better sensor system. Yeah.
Okay, so with this we come to an end for the mandatory courses in the second semester.
Yeah.
So now I think we should cover the mandatory course in the next semester, in the third semester, and then we can talk about electives as a whole. And for electives, the thing is that I've written down the subjects that either of us has taken. So some subjects he has taken, some subjects I have taken, and that's all we can share with you. This particular subject, simulation of robotic systems, sensors and environment. This is a mandatory course in the third semester, and this has a lot of content. This has a lot of the lecture slides are like 130 or so slides per lecture.
It's out of all subjects, what I experience is like the content is too much in this particular subject.
Yes, exactly.
It's very important, each and every concept, of course, but it will of course it covers entire robotics, but in a simulation perspective, because simulation is one such topic which is very, very important in industries or maybe in research oriented perspective, because we would want to simulate robotic systems in order to avoid damages, in order to
test on a simulated system first,
and
then
to
a
gather
real
more data, maybe. So here we were talking about like here the subject deals about how you can simulate a robot and robot perception,
and also how to design a simulation system for
So what is a simulation, what are the simulation systems, what are the elements of simulation, and how you can use robotics in simulation, how you can use simulation in robotics. Also you will learn how to simulate a robotic system, you will learn how to simulate sensors, you will learn how to simulate environment. Yep. So, but content is too much, of course, but no need to worry about the number of slides, so
Yeah,
much of
exactly.
content, because exams are more or less concentrated on exercise part.
Exercises.
And of course, you should study content to attempt some of the questions in exam, but more or less it is concentrated on exercise part.
Yeah, so you should focus on exercises, but we also have theoretical questions from the lecture, so you have to focus on both, mostly on exercises.
Yeah.
Right, so with this, we kind of come to an end for all the mandatory subjects. Hey guys, I really hope that you enjoyed this particular conversation and it helped you in some way, shape, or form. If it did, make sure to hit the subscribe button and the notification icon or the bell icon so that you can get notified on time whenever the next part is out. Also, it would be really great if you could give me your feedback in the comments below. That would really help me improve. I'm uploading small clips of the long podcasts on a regular basis on platforms like LinkedIn, Facebook, and Instagram, so make sure to follow me on these platforms if you're someone who cannot take out time for the long episodes. The podcasts are also available on all major podcast platforms including Spotify and Google Podcasts. So if you're someone who prefers to listen to podcasts rather than watching full-length videos, make sure to follow on your favorite podcast platform. Thank you very much and see you next time.